Episode 43 of the Photon Podcast. Microcontrollers, guest host, and more coming up. Welcome into the next show, the Photon Podcast. It is episode 43. I'm Cale, your normal host, but I'm out of town, so when the cat's away, the mice will play, and George and Jeremy are coming in to do a great job for you. They're going to be discussing microcontrollers, Linux, and other maker things that you may be able to use to enhance your ham radio experience. So make sure you stay tuned for that. Hey, by the way, there's a giveaway mentioned in here, and you don't want to miss it. So make sure you listen all the way through to get the giveaway terms and conditions, and maybe we can put something in your hand. Hey, this portion of the Photon Podcast is sponsored by Main Trading Company, your source for all things ICOM radio. That's right. You need a new handy-talkie, you need a new base station rig. You know, tax time's not too far away, so I bet you got your post-Christmas list ready. You need some ICOM gear, make sure you check out mtcradio.com today.
All right, thanks, Cale. Hey, George.
Hey, Jeremy, how are you?
I'm good. Looks like we're in charge again.
Is Dad gone again?
Dad is gone again, off into the wilderness of the Great Smoky Mountains. I'm imagining he's out there right now with his shirt off, with a stick in his hand, hunting some kind of bear, which would be hibernating, so that's probably illegal.
And to think he left the keys to the car in the house with us.
Indeed. Of course, he doesn't realize that we made a copy of him last time he was gone. So, you know, I think one of the things that's actually really cool for me about tonight, Happy New Year, by the way.
Happy New Year.
One of the things that's really cool for me is that this episode is kind of coming full circle for something that I realized early on in Photime. If we go all the way back to episode 5, when we had Nick of Pignology on, one of the things that I loved about having Nick on and several of the other small, innovative product companies, including yourself, is that it is a bridge to amateur radio, which may be one of the first maker hobbies being connected to the modern maker in playing with microcontrollers and single board computers and using all of this relatively easy to cobble together things that we have at our fingertips to innovate and to create things for amateur radio. And so tonight we are going to talk about just that. We're going to talk about microcontrollers and single board computers. And I mean, do you agree that that kind of bridges the gap between the original hams and us today?
Oh, yeah, absolutely. I mean, really, when you look at technology hobbies, I mean, really ham radio was back in the 20s, and, even earlier was really this a space for technology experimentation, much like a lot of the computing and other maker kind of activities are today. So there's a big crossover, absolutely. I mean, certainly the spirit of it is very similar, and there's a lot of people who are active in both communities.
Now, one of probably the most exciting thing in the general maker movement, of course, if you don't know what the maker movement is, the name comes from a publication that started back about, 7-8 years ago now, Make Magazine?
Yeah, a little bit further probably.
But I mean, it was a group of people that started a magazine that, believe that people have the right to open up their electronics and repair them and experiment with them. And over the last several years, I mean, this community, this maker movement has really exploded. And we're going to focus on, like I said earlier, microcontrollers and single board computers, because this is probably, especially with the recent announcement and release of the new Raspberry Pi Zero, and of course, all the great products that are out there under the Arduino banner, it's just an amazing time to be alive.
Yeah, actually, it's an amazing time, and I would add it's a very confusing time, because there's been such an explosion of different platforms that I think it's pretty bewildering if you're just starting out.
Yeah, it really is, because I mean, it kind of goes. I mentioned in the D-Star episode, I think that as a new ham, I was confused. What's the difference between D-Star and APRS? And of course, those two things, other than the fact that it's a digital technology available on a radio, have nothing to do with one another, essentially. And I think the equivalent to that in this arena is an Arduino versus a Raspberry Pi, because those are really the two platforms that have probably gotten into the hacker maker ham zeitgeist most prevalently. Although I do want to mention we will also be talking about the PIC tonight, because obviously the PIC was doing easy to use home programmable microcontroller before that was cool.
Mm-hmm. Yeah. I think those are really the Arduino and the Pi are really the most well-known ones, and probably the ones ultimately that someone would want to start with, because there's a huge community out there for both of those. But on first blush, you might ask yourself, well, like, what's the difference? And there really is an enormous difference when you get into it.
All right, so that's a really good jumping off point. Let's go ahead and start going down the road. So the two categories of devices we're talking about, as I've said, are microcontrollers versus single board computers or embedded Linux systems. George, what's the difference between those two?
Well, the simple way to think about it is a microcontroller is a single chip that has all the basic hardware features of a system built into it, which means the processor, memory, both RAM memory as well as program storage memory, and peripherals like input-output ports, analog to digital converters, PWMs, pulse width modulators, etc. So it's everything in a single chip, and it's programmed typically to do a very specific fixed function, as opposed to a Raspberry Pi, which is really a computer running a general-purpose multitasking operating system like Linux that is shrunk down to a very small size. So it has many of the attributes of a microcontroller, but with a lot more storage, a lot more processing power, a much more sophisticated software environment, usually communications like Ethernet or Wi-Fi or Bluetooth. So really, it's a much more sophisticated computing platform.
All right, and what's also kind of doesn't help is probably the most prevalent Arduino that's out there as a microcontroller platform is probably the Uno. About how much does an Uno run for?
Well, the Unos, when they first came out, this is a board with a microcontroller and a little voltage regulator and a couple little support parts. Brand new, those were about $25 to $30, and today you can buy them for as little as under $10.
And what's interesting is on the original Raspberry Pi and even the Pi 2 are also kind of in that $30, $35 range, and of course they now have a $5 model. And so obviously looking at prices alone is not really a good guide as far as to the capability or what you're going to get out of the box.
Yeah, that's really true. The criteria for picking it is much different. It really is more along the lines of do you want it very real time? How complicated do you want the software environment? Do you need communications infrastructure? There's many other things to look at.
So at a high level, can you kind of sum up the differences between the individual little microcontroller and give me some examples of things you would want to use that for versus the embedded Linux system or the single board computer?
Well, so there's really multiple things to compare. One thing is, what are projects that are more applicable for a micro versus a embedded Linux? You can also look at the hardware. What is the hardware difference between these worlds? So let's take a kind of a top level look at that. If you're going to build a project where you have a very specific function you want to have take place, you want it to be pretty fast in real time, and it's kind of a dedicated chip or dedicated piece of hardware to do that task. Typically, that's done with a microcontroller. If you want to do more complicated applications, especially with a lot of communications, then the Linux is better. So, for instance, microcontrollers are great for building a keyer, building a let's say a T-Hunt transmitter controller, repeater control system, things that when they power on are going to wake up and do that dedicated function and be very robust and very reliable and with a very fixed purpose in mind. With a Linux single board computer, since you can run many different programs simultaneously, it's a more complicated software environment. So applications where that's better might be let's say if you want a graphic user interface, if you want Ethernet or Wi-Fi connectivity, or if you want to run multiple tasks simultaneously, then the embedded Linux board's better. Now, somebody listening to this, I'm sure, is going to say, well, hang on. I can build a keyer out of a Raspberry Pi just as easily as I could build it out of a microcontroller. That's true, but one of the differences is with a microcontroller, the moment you apply power, it's executing its task in real time. With an embedded Linux board, there's a boot time. So from the moment you power that thing up, it's going to take you several seconds before it's really fully operational. So that's one of the subtle differences between the two.
Well, folks, over the next little bit here, I knowing how you and I get to carrying on, I'm not brave enough to actually put a time on it just yet. But over the next few segments, we're going to kind of deep dive into microcontrollers as far as what they're good for and some specific projects, as well as the single board Linux systems. Then at the end, we're going to give you a far more examples of how these things are used in amateur radio today. And then we might just have a surprise for those who make it to the end as well.
Ooh, so, what kind of surprise?
There may be some things that we may have in our possession that we may want to put in the possession of our listeners. So we'll be right back after this break. You're listening to Jeremy, KF7IJZ, and George, KJ6VU. Don't go away.
This portion of the Photon Podcast is brought to you by our brand new show sponsor, Bridgecom Systems. Check them out at bridgecomsystems.com. If you're looking for some 220 equipment, they're the go-to source, bridgecomsystems.com.
All right, we're back. So, George, why don't we dig into microcontrollers first? Because I think it's fair to say those have been around much longer than the single-board Linux computers.
Yeah, for sure. Microcontrollers have been around for 30 years, so they've gotten faster and more capable, but the idea has been around for a long time.
All right, well, kind of start us off. As far as maybe amateur radio or the home hacker, where did microcontrollers really start?
So there were several manufacturers of these things over the years, and if you look at the industry, the leading suppliers have changed over time as companies kind of come and go. Probably the most famous companies were Intel and Motorola, when Motorola had a semiconductor business. So parts like the Intel 8051 are legendary. They've been around for decades. You can still buy them, which is amazing to me. Motorola had the 68K series and the 6K series. The 6K is more as embedded processors. Those are gone these days, and they've been replaced by other vendors. Today, the most popular ones you hear about in the hobby community are Atmel and Microchip. Microchip makes the PIC processors, and Atmel makes a variety of processors, including the CPUs that are used in the Arduino boards. Probably the third most popular one that really has become very popular in the last 10 years is ARM, which is a UK company. They developed some very small, very low power microcontrollers over the years, and so they're becoming increasingly much more popular.
Now, that last one's interesting because I would expect that when we talk about the embedded Linux boards, you would be talking about ARM processors there. Well,
that's because all of these vendors have a range of processor families. So all of them go from smaller, lower cost, lower performance processors to higher performance processors that can support a multitasking operating system. So ARM, for example, has their A series, their Cortex processors that are in the Raspberry Pi, but they also make the M series of microcontrollers to compete at that lower end.
Okay, so, for one of the things that we're kind of taking for granted is you and I you're very conversant on this subject. I am conversant enough. But when I go out and I'm the hobbyist buying these things, I'm not just buying, a chip right? I'm buying a chip that comes installed on a board, and that board will have some features.
Well, maybe. So if you rewind in time, let's say more than 10 years ago, you really didn't buy a board with a chip on it ready to go. What you bought was the chip, and you designed your circuit. Let's say if I'm building a keyer, I would buy a microcontroller chip like a PIC or an Atmel chip, and then I would design the circuitry around it, and I would code it, and I would make my own board or wire wrap it or prototype it somehow. The big change in the last several years has been the growth of pre-existing PC boards with the microcontroller already mounted on them and a bunch of sockets, so you can get accessories and plug it all together and make a system more easily. And that's really kind of where it's at today. So there's really kind of two levels of this, and you might think about it in the following way. If I'm building a project and I want to whip something together quickly, I could take these existing boards and I could stack them, or I could put jumpers between them, and I could cobble together my project fast. If I'm going to build something where I want to make several of them, or I just want to make one but I want to make it as small as possible, I may still design it with a discrete microcontroller chip and my custom logic sitting around it.
Okay, so if I do look at the thing that I'm going to be able to walk into a Micro Center, or when I used to be able to walk into a Radio Shack, I am mostly going to be buying boards today.
Well, that's true, but I would add that once you are familiar with this kind of environment, it's not unusual to make a project with a raw microcontroller chip. Because it's really easy. If you look at like the Arduino, for instance, you could just replicate the Arduino circuitry on your own circuit board. If I was building, let's say, a radio, and I wanted to use a PIC or an Atmel chip as the brain of that radio, I could plug in a board with a microcontroller on it, or I could just incorporate that microcontroller circuitry right into my circuit board. I could do it either way. But if you're starting out, you're right. You're probably going to go out and just buy these pre-existing boards and then just jumper wire them together to get your project going.
All right, so for the pre-existing boards, and I'm going to be honest with you, I'm going to have a bias towards Arduino because just to kind of put my 2 cents in it, Arduinos were the first. Well, actually, I'll take a step back. What's interesting is I happened to go to a conference in Indianapolis back in 2003 or 4, maybe 2, a good friend of mine who lives in central Kentucky was getting into the business of building calculator-based laboratory hardware to compete with for a contract that Texas Instruments had to connect to the TI-82. And we went to this Atmel kind of trade conference in a hotel where they were announcing the introduction of the AVR line of microprocessors or microcontrollers, which is the chip that is on the Arduino. And I still actually have my little AVR name badge that had the scrolling LED display on it. That was the demo kit that they gave all the attendees. And then lo and behold, 10 plus years later, up pops Arduino. I'm like, wow, that's that same microcontroller that I went to that conference that I understood nothing about. So that's why I'm going to have a bias towards that. Also, I feel like in again that kind of maker zeitgeist, the Arduino, just the community was built up for whatever reason, happened a little bit more than some of these other platforms. Would you agree with that bias, or are you biased towards another platform?
That's a tough question. I think if I were really trying to be objective, probably Arduino really has the advantage because of the community, because there is so much consumer technical hobbyist content out there that's geared around the Arduino version of with the Atmel chip on it. We should explain what the difference is in a moment. But personally, I've spent the last dozen years developing projects on PIC, so I'm familiar with the PIC family, and so I tend to use that. But the real advantage is not the one chip over the other. So frankly, the microcontroller chips itself, the PIC versus the Atmel chip, it's a wash. It's a Ford or a Chevy. There really is like virtually no difference between the parts at the hardware level. They're identical. When you go up a level and look at the professional development software tools, they're similar. I wouldn't say they're identical, but they're very similar. So there's a complete software development tool for professional software developers for both. Where the Arduino comes in is these guys took the Atmel chip and put it on a circuit board, and their real value add was that they created a C compiler with a library that made it easy to write software for that Atmel processor. And they could have just as easily targeted the PIC processor, but they chose Atmel. So the Arduino is what it really is an Atmel CPU, just like equivalent to a PIC, but with the Arduino software development tools on top of it. And that makes it a little bit easier than the professional development software tools, which are a little more complicated because they're trying to provide a high degree of functionality to commercial developers.
They also were a lot more expensive.
The tools essentially have all come down to not much to free. So when we first did our repeater controller systems 10 years ago, we bought the PIC optimizing C compiler, and it was $500. And today I think it's free, or cheap. Oh, wow. So the prices of the development tools have come down significantly. Arduino software development tools are free. So I think the development tools just for raw AVRs I think is cheap to free as well. So very comparable to the PICs.
Because I remember at that conference, the buying the C compilers for the AVRs were scary expensive for somebody who was still an undergrad. But let's not go down the software road just yet, because we still, if we look at you're going out and you're buying an Arduino, or maybe you're going to receive one in a giveaway we haven't talked about yet. What else am I getting on the board besides the chip? Or, the Arduino, the PIC, whatever. I mean, because it's great that I have a chip. A chip can run a program, wonderful. But at the end of the day, right, I'm using these things because I want to interact with either other devices or stuff in the real world. So if I'm brand new to all this and I have no clue what we're talking about, I don't understand how to plug something into a chip. So what else is on that board?
So there's really not a lot on the board, actually. So what you get on the board is the processor chip itself. There may be a crystal that's the clock for the clock circuit. There will be a voltage regulator that'll take some external, 6 to 10 volts or whatever, and bring it down to the operating voltage of the part, which is 5 volts typically with these parts. Well, it could be anywhere from 3.3 to 5 volts. The Arduino's 5 volts. And there's usually some connectors and a reset button. Most of the pins of the processor are wired out to a set of header connectors. And those pins are the raw CPU pins pulled out to a connector for you to hook stuff up to. So the real question is, there's not much on that board. The question is, well, what do those pins do? And how do I connect that physically to the real world? So when you look at the pins, and this is true for any microcontroller, whether it's a Atmel or a PIC or an ARM or anything else, those microcontroller I/O pins, there's a few different flavors. You can have a digital input or a digital output, which simply means a 5 volt, let's say a digital output, the pin will either be 5 volts or 0. A digital input means that you can give it 5 volts or ground, and the software will either set that value on an output or it'll read a value that you give it on an input. So that's the simplest thing. Then there's a bunch of special purpose pins. You might have an analog to digital converter, and an analog to digital converter, or ADC, is a little circuit inside the chip that looks at a pin, looks at the voltage on the pin, and gives you a number based on the voltage that it sees. So if, let's say you have a 5 volt part, and there's a ADC pin, and it reads 0 to 5 volts, if you have a 10-bit, what's called a 10-bit ADC, or 10 bits of resolution, it'll look at that voltage and it'll give you a number between 0 and 1023. And it'll tell you, for instance, if it sees 2.5 volts, that's halfway, it gives you the number 512 to your software. So it converts that voltage reading to a number. Another kind of I/O pin could be a UART, Universal Asynchronous Receiver Transmitter. A UART is a serial port. Just like we had on our PCs 10 years ago, you often find UARTs on the microcontrollers because microcontrollers are often used to control hardware that might have a legacy UART on it. You might also find a digital serial data channel. So there's a lot of peripheral chips in the microcontroller world that talk to the microcontroller over one of these special buses. And there's 3 very commonly used buses: SPI, I2C, and OneWire. These are buses that allow you to talk from the microcontroller to the peripheral. So let's say, for example, I have a temperature probe, a digital temperature probe. How do I get the data from that temperature sensor into the microcontroller? Well, it could be a pair of wires like a I2C interface, or a single wire like the OneWire, which is a name, interface. And there's protocols that are used, software commands that are used to talk to these peripherals. And the thing that's really cool about this is if you look at the chips that are out there, there are sensors for every conceivable kind of sensing. You can measure temperature, you can measure current, you can measure strain, you can measure humidity, you can measure gases, you can measure all kinds of things. And there's hundreds and hundreds of sensor chips out there that could be hooked up to these microcontrollers. So that's on the input side. So that's kind of a quick list. There's more specialized pins, but that's kind of a high-level view of what's available. And this is, like I said, true for all these microcontrollers.
No, I think that's a very good overview, because one of the things that when the light bulb went off for me about why I cared about microcontrollers, in addition to all the things that we said about it being a little bit more real-time, which actually isn't quite true with the Arduino, but that's another topic. Most people wouldn't know, but there's actually a layer of software that runs between the hardware and the programs you write. But it's an opportunity to use a small computerized chip to somehow interact with the world, either getting inputs or providing outputs. A good example of what I have used in Arduino before is for my portable solar operating. I was able to buy these sensors you're talking about that were very wide dynamic range luminosity sensors. Bought them from Adafruit, which is a company that really kind of helped, I think, pave the way for the Arduino, and they're very supportive of the maker and hacker movements. But anyway, I put these sensors on my solar arrays and used an Arduino with a little display to tell me how to aim it to get the most optimal light. And if I had wanted to, I could have gotten what is called a Shield, which is a peripheral device that plugs into a standard pinout in the Arduino case. That is a set of servo or motor controllers, which would have allowed me to actually automate having a solar array being aimed at the sun at all times.
And that's a good example where you don't want a fussy, complicated device. You have a very specific fixed application in mind. You want to measure something and you want to react to it.
I need it to just go.
Exactly. You want it to be super reliable, and frankly, inexpensive isn't bad either. So that's a great application for a microcontroller.
So, once I have, we've talked at a high level all these interface opportunities, but and we brushed on it a little bit earlier, but let's talk about the software.
Yeah, and this is one of the things that's changed greatly over the last decade. If you look at the software development environments for most of these parts 10 years ago, there was a lot of assembly language programming. What that means is you're really...
Well, that means that people like me are scared away. That's what that means.
Yeah, well, me too, frankly. And that's really changed, and it's gotten way better. So what assembly language is, it's a very low-level way to code a computer, which uses the operation codes, the opcodes of the processor itself at a very low level. So you're really giving the CPU chip like the lowest level of command possible, and it's the sort of thing that was primarily done really by professionals who would do this full time. And it was really, only a precious few hobbyists would be willing to go through the time and effort to really understand all that. And the big change in the last 10 years is the introduction of higher level programming languages. And in the professional embedded world, that's primarily C. And you'll see today in a lot of projects, the microcontrollers are coded in C. Maybe there's a little bit of assembly language, maybe not. What you also see in the last 5 or 6 years is languages like BASIC. There's even an old Pascal, believe it or not, Pascal compiler, and other kind of structured programming languages. A really good example of an old processor that was coded in BASIC was called a BASIC stamp. Do you remember those things?
Oh, I sure do.
And most of us who first played with microcontrollers used BASIC stamps because they were super easy to program, and you can still go buy them. There's a company here in California called Parallax that makes them, and it's a little module, looks like a big chip, and it actually has a PIC on board and a BASIC interpreter, and you write your program in BASIC, and you load it in there, and it runs the program. The problem with the BASIC stamp parts is that they were very expensive. They're like $50 just for the chip. And if you are a clever programmer, you can buy a $3 PIC to do the same task, and it would have more memory and be faster. So you pay this enormous penalty and cost for the BASIC stamp. Now, today you can go get a BASIC compiler for free for a PIC. There's probably the same thing for the Atmels, or you can use the Arduino C compiler, which is free. And so now you have these high-level languages, and with the in the case of the Arduino, there's the Arduino libraries that have all these pre-existing functions to let you make interacting with some of these peripheral chips even easier. So then, what this really means is the number of lines of code you have to write has gotten very small.
I want to tell our listeners that, again, a lot of what we've talked about could scare people off, but one of the best things, and this is where I'll go back to the Arduino, is the value add here is the community. The software is open source. These libraries that George just mentioned are open source. Pretty much every peripheral that you could connect to an Arduino that Adafruit sells, they give you the code and very easy to follow step-by-step instructions on how to use it. For me, because I was a terrible developer. That's why I got into management, because those who can't do manage. And the thing was, like, I always struggle with that. I understand algorithm design. I understand all those high-level details. But when it came to actually writing code, I would get lost. But with the Arduino, the first time I opened up the free Arduino editor, and the sample program is blink, because there's an LED on board, the Arduino board, and the default program just has it blink at like a 1 second cycle time. And for you to learn, you just get in there and start playing with things. You're not going to zap it. You're not going to cook it. You're not going to destroy it. You're not going to break anything. But once you kind of understand that structure, you feel a little bit more comfortable. Plus, on top of that, there are a million great tutorials out there about learning the version of C that has been, I guess, pared down for the Arduino or these other platforms. And so it really is an awesome opportunity to start tinkering around with development and seeing those results come out in the real world. And it actually is kind of a rush that as you get better and better and you start adding skills and starting to learn how to interface with more things, that in and of itself for me has become quite addictive.
And once you build a project, you want to take that core and repurpose it for something else and build the next thing, and that's really fun. By the way, I would hasten to add, I'll give you the PIC version. While the community of kind of in the hobbyist world is much greater on the Arduino Atmel side of things, we had done a fair bit of work around a PIC platform using a BASIC compiler, and the BASIC compiler makes it in many ways, just as easy, and in some ways easier actually than the Arduino C code. So if for some reason you want to go down the PIC path, it's not that it's intrinsically harder. There's not as many, I would say not as many hobbyists using it, but in the commercial world, there are probably as I don't know who's bigger, Atmel or Microchip. I think Microchip actually is a bigger market share, but that's not relevant really for us. But if you want to write the Blinky program, you could write that in like 4 lines of code in BASIC for a PIC. So I don't want people to get the misconception that PIC is hard, Atmel is easy. They're both pretty easy, but you're totally right about the size of the community on the Arduino side is really massive. So if for no other reason, I think that's a sound advice to go down that path if you're looking at it for the first time.
All right, so at this point, we've kind of given... I feel like in some ways, if you're not familiar with this, we've given you a very deep, very broad introduction. In other ways, if you are familiar with this, we haven't even scratched the surface. But again, this is kind of a new frontier for some folks, and that's part of what's exciting. And there's so much to learn and so many people who have gone before you. In our next segment, George, I think it's time to move on from microcontrollers and step up to the single board computers. What do you think?
That sounds great. Let's do that.
All right. We will be right back.
This portion of the Photon Podcast is brought to you by Kenwood USA and their THK-20 Alpha, which is a single-band, 2-meter handy-talkie. Now, this is just the handy-talkie season, I guess, for me, but it's been a great little rig. Really impressed with the build quality. Of course, you're going to get the great sound quality as well from Kenwood, and you can find it online at mtcradio.com.
All right, you're back with George and Jeremy. Let's talk about single board computers. And I'll just go ahead and say it. My bias is definitely going to be around the Raspberry Pi, which was my formal introduction to single board computers.
Well, just to make this spicy, my favorite is the BeagleBone.
I know it is.
So we could debate the pros and cons.
It's actually interesting, though. It's interesting because me as somebody who was truly just a hobbyist, right? I have absolutely zero professional connections towards playing around with electronics, microcontrollers, single board computers. I came to them. I came to Arduino because of the public hype about Arduino. I came to Raspberry Pi because of the public hype about Raspberry Pi, whereas you have a bit more of a professional acumen with these things, and I find it interesting that you are going, you have a preference for the PIC, and you have a preference for the BeagleBoard, or the BeagleBone, which at the time the Raspberry Pi came out was actually a more powerful platform. But okay, that's fine. So this is our beans, no beans breakups, which I think is wonderful. And it's really cool that we have these very different approaches to the hobby. So, George, define for us the single board computer.
So this is the biggest radical change in what's been available that I've ever seen in computing. And what we're really talking about is taking the functionality you would only have ever found on a desktop computer and moving it down to something the size of a deck of cards. And I'm not speaking too hyperbolic here. When I say it's the same power as your desktop, I don't mean a current desktop. I mean a desktop of circa 10, 15 years ago, but every bit as powerful as that. So the single board computers are a circuit board with all the chips necessary to run a full multitasking operating system, Linux. And most of these boards support other OSs like Android, which is kind of a derivative. But mostly they run Linux. And today, most of them are running ARM processors. Frankly, not that it matters. Just like in your PC, running Intel or an AMD processor, for the most part, for most of us, makes no difference. But most of these single board computers are running an ARM. And then it's a question of, well, which processor, some have more performance than others, and what peripherals are built onto that board. So the Raspberry Pi, the BeagleBone, and other similar boards have a CPU chip. They'll have a SD or micro SD card for the functionality of the disk. So the disk is a flash memory device. They'll have RAM built in, chips soldered to the board. They'll have some communications interfaces. Maybe they might have wireless or not. They'll have a power voltage regulator circuit typically. They may or may not have video. Most of them do have video out. They may or may not have audio. Just depends on which board it is. And like you said, Jeremy, originally the Raspberry Pi, when it first came out, was good and inexpensive, meaning $35, and it was pretty good. And the BeagleBone was $99 or $89, and it was faster and more of an industrial processor. What's happened over time is the Raspberry Pi, for that caliber, that class of Raspberry Pi, the price has stayed about the same, but the performance and the I/O and the feature set has gone up quite a bit. And the Beagle has stayed about the same functionality, but they've reduced the price down to about $50. So they're now really converging. And I would say if they both were introduced today with the current models, it really would be another Ford and Chevy comparison. I mean, they'd be very similar, and you'd be making the decision on some rather secondary criteria, which we could talk about. But they're really converging to be very similar, and they're running full-blown Linux operating systems.
Which is really cool. I mean, that's another area where community open source wins outright, because I'll go back to, you may or may not remember this, but in the late 1999, early 2000 was the first time that I had come across the concept of and I'm going to use the word microcomputer, not in the way that our forefathers used it. But there was a computer, a Linux computer that was available that would fit inside of one of the old IBM mechanical keyboards. And it was about the size of a paperback novel. And it had something stupid like 8 megabytes of RAM, ran a 486 equivalent processor. Don't even remember what it had for storage. But I mean, everybody thought that was the bee's knees. And then later came the Matchbox computer, which was another single board computer that ran a full version of Linux with some type of an embedded processor. And of course, these things were thousands of dollars because you were paying for the size of the miniaturization. And now I can buy a Raspberry Pi for $5 that is like 1 million times more powerful a computer than what landed a man on the moon. I mean, just think about that. So
yeah, it's really amazing.
If we, I guess right now I would say probably the BeagleBone and the Raspberry Pi. Then, would you agree those are kind of the two most prevalent common boards you're going to run into that have good community support behind them?
Yeah, I would say yes. Raspberry Pi being number one in terms of community awareness and support, for sure. I would say Beagle is definitely number two, and then everybody else. And there are a lot of newcomers, and a lot of them are from groups of people you've never heard before that are jumping into this crowded space with similar things with a slightly different spin. There's also some really big names like Intel is jumping in a big way with their Edison and other platforms. So NVIDIA even has a new one that's a high-performance single-board computer. So there's a lot of new entrants into the space. But I think for our purposes, you can't go wrong with a Raspberry Pi. And there's some reasons why you should consider a Beagle. And we could probably talk about what some of those differences are. All
right. So before we get too much past this, we talked about the hardware on the microcontroller front. So if I'm out to buy one of these things, what else comes on the board? Because obviously I have a much more developed processor that is more akin to what's in my personal computer or my smartphone than just a simple microcontroller.
Well, conceptually, they're almost the same in that whether it's a Arduino microcontroller board or a Raspberry Pi, both of them have the core processor. Both of them have a way to store the programs. Both of them have RAM to execute the program. Both of them have raw I/O pins brought up to some connectors. Both of them have some kind of voltage regulator built into them. And kind of at that basic level, I mean, they're sort of the same, except, of course, the microcontroller is very scaled down in its specs. It's going to be 1/10 of the performance. It'll have a very small fraction of the amount of memory, etc. So there'll be some differences. One thing that you tended to see in hardware is that the microcontrollers tend to be very light on processing performance and memory, and so you're always concerned about getting your program to fit in the RAM. But they have a very rich physical interface. In other words, on a 40-pin microcontroller, 30 of those pins are typically available for I/O, for analog to digital converters or digital inputs and digital outputs and all that. On the single-board computers, they tended to be more compute-centric, lots more memory, lots more performance, but a very limited amount of physical I/O. So they would have, like on the original Raspberry Pi, there was only about a dozen I/O pins. There's no analog to digital converters. They're really very, very simple. There's one UART on the original Raspberry Pi. If you look at a PIC even, a PIC has 30 I/O pin, including analog to digital converters, including multiple UARTs. So you tended to find the single board Linux things were more compute-centric with not much I/O, and the microcontrollers were lots of I/O with not much compute. To some extent, that's starting to change because the new generation of Raspberry Pi has a bigger GPIO or general purpose I/O connector. It's got like 20 I/O pins. And
it's even more than that because the original Pi had 26 pins total. I think 3/4 of which were in, but now there's 40. And so there's a lot more of that on board, as you were saying.
Yeah, and more, even more so on the Bone, which, by the way, is the reason that I did more work on the Bone than the Pi. One reason is that there's a lot more I/O on the BeagleBone than on the Raspberry Pi, even today. So if you're doing a lot of industrial control and need a lot of I/O and UARTs and all that stuff, there's more on the Bone.
Now, some of the other things that come on those boards, which you start getting into the territory that the average PC user is familiar with. For instance, both the BeagleBone Black and the Raspberry Pi both have a built-in Ethernet controller and an Ethernet port. And that's another one of the chips that are on the board is the hardware to do Ethernet, as well as the hardware to do USB. The current Raspberry Pi 2 has 4 USB ports. I'm trying to think if there's anything else, like from a peripheral standpoint, that I'm missing on those guys. The graphics. That's something else that's interesting is that, a lot of people are familiar that they have a computer and maybe they have a secondary graphics card. Both the Raspberry Pi and the BeagleBone Black have little tiny coprocessors in there for the graphical unit. Graphical performance on the Raspberry Pi is actually better because it was built to be able to display high-def video as opposed to the BeagleBone Black, which was just, I think it can only do 480, maybe 720.
I'm not sure what the video is on the Bone. Tell you the truth, it's at least VGA, but you're right. The Raspberry is really, if you're using it as a conventional computer with a HDMI display and all that, then the Raspberry is kind of a better way to go.
Yeah, I mean, an entry-level project, like a lot of people who will buy a Raspberry Pi that may not be very familiar with these things will use them to build kind of little miniature home theater PCs or like Xbox Media Console or Plex type things where they're displaying media on their home computer. It also has built-in audio capabilities as well, both analog and over HDMI. So definitely built, their mission was around education. It's certainly a more consumer-y device. But I remember when the Pi first came out, the BeagleBone Black still was, from a computing perspective, like you said, just a much better performer in just raw compute power.
And still is today. I mean, if you kind of take a deep dive, the processor in the BeagleBone is similar or better, but it also has 2 digital signal processing coprocessors buried inside there. That's because the chip is made by Texas Instruments. It's called a TI Satara, as opposed to the Raspberry that's a Broadcom chip. And the TI Satara was really an industrial controller, so it's designed to be able to do things like real-time servo motor control and stuff like that. So it's got a super powerful processor in it to do other things. Plus, it's got like 4 UARTs, and it's got a lot more going for it on the physical control side. So I think for me, if I were going to build a project, if my project was more media centric, I think the Pi is way better. If it was more control real-time centric, I think the Bone is better. But for many ham applications, that'd be fine either way.
So now that we've kind of, given a pretty good overview of the hardware, the next layer down, it's not like the microcontroller where I'm just going out and writing a program and then uploading it to the microcontroller, because this has, the entire power of Linux on it. You can log into Linux over SSH, you can run a web server, you can run Java on it, you can pretty much do anything on these as long as there is software available that you could do on a desktop Linux machine.
Yeah, and surprisingly, you can get the desktop Ubuntu, and you run a full graphic UI on the thing. And it boots up just like any computer, and there you go. It's remarkable.
And what's interesting is that on the Raspberry Pi front, there are several flavors of Linux that are available, but the most popular is definitely Raspbian, which just saw the release of Jessie as the latest. And Raspbian is based off of Debian, which is one of the original earliest Linux distributions, and actually it's been my personally preferred distribution for years just because of packet management and the real dedication to quality software that they've had. What are they running on the BeagleBone Black on average?
Currently, the recommended core OS is Debian. You can also run Ubuntu. The original version was called Angstrom, and Angstrom was really kind of an odd offshoot of I think an embedded. I forget what it's called, but there's an embedded derivative of something way long time ago. But now it's really Debian centric. So that's kind of the good news, is whether you're going with the Bone or with the Pi, it's the same kind of branch of the Linux family.
Now, on top of that, I kind of glossed over this earlier, is kind of like the Arduino boards where there's a standard for peripherals called a shield that interface with all the pins. Both the BeagleBone and the Raspberry Pi have this hardware standard for accessories. On the Raspberry Pi, they're called HATs, which I just remember what it stood for, but I think it's a hardware attached something. Do you remember what HAT stands for?
I have no idea. I hate those names. So.
Everybody has to have their own thing that goes on top. On the BeagleBones, they're called capes.
Right. That's right. They're dumb names.
But as an example, like at my local Micro Center right now, there's hats available for the Pi that give you a GPS that directly interfaces with the Pi over some of these, as George had mentioned, these I2C or the SPI interface or the UART. Actually, Raspberry Pi Foundation has released a board called the Sense Hat, which is kind of cool because it gives you an 8x8 grid of multicolored programmable LEDs. It has onboard position, like 3 degree of freedom, like accelerometer data, a magnetic compass, pressure and temperature and humidity sensing, all on board this board that they designed for this mission that is on its way up to the International Space Station. I actually used one of these for my daughter's Halloween costume this year. And that's a really good tie-in to getting back to the software beyond Linux, because I was able to program my daughter's entire costume, which was to use the bright LEDs to draw all these different glyphs, and it would change color based on the ambient air temperature and humidity and barometric pressure as inputs to this. But I did it all using Python. George, what's Python?
Well, Python is a programming language that's become super popular. It was originally invented about 22 years ago, and is used very widely in all kinds of applications. And it's a fairly easy language to learn. And when I first picked up Python, the best resource that I found was a online tutorial, a lecture series that was available from Google. So if you go to Google and search for like Python tutorial YouTube, you'll probably find the whole series. And there's a guy from Google who actually teaches you the class, and it's excellent. You just watch it online, and easy to learn. It's very readable syntax. It's easier to code than C. And there's tons of libraries for all kinds of functions in Python. So if you're just learning to program today, I would say Python would be a very good language to learn.
Now, I'll add to that the reason Python and Raspberry Pi are so, I guess, synonymous, or Python is very synonymous with Raspberry Pi development, is that the Pi Foundation, a lot of the original libraries that were released in order to get at the general purpose GPIO, or general purpose input-output pins, were made available through libraries that were written for Python. And so you didn't have to understand this low-level driver writing that you would often have to understand for interfacing with these chips. They made it very simple for you. And of course, now those libraries to access those pins for input and output are available pretty much in every language that will run on there. Now, if I'm looking at BeagleBoards, is there a preferred development language on them, or are they literally open to anything?
No, it's really open to anything. It's similar to the Pi. You find that most people are writing in Python or C or Java, but that's not unique to the bone. That's pretty universal. I would say the same thing about the Pi as well.
So another thing I just want to call out real quickly over the lifespan. I should have done this for the Arduinos because I found a list on the official Arduino website, and there are currently in production like 48,000 versions of the Arduino based on how many inputs, outputs you need, what voltage it needs to run at, how much processing power you need. The Raspberry Pi in production today, you can pretty much find 6 models. They're the new released $5 Raspberry Pi, the Raspberry Pi 2, which is a quad-core, the current most powerful Pi, the Pi B Plus, which is an upgraded version of the very original, the Pi A Plus, which is an upgraded version of the A, and then something called the Compute Module, which the average person is not probably going to play with because it's basically a Raspberry Pi on a module that looks like the memory that goes in your laptop. But those are all available, and they're a lot of fun. I mean, the cool thing is I think we've given a pretty good introduction and overview. I think it's time that when we come back from the break, we should give a good 360-degree overview of what hams could actually use these things for by, looking at some of the links we're going to provide in the show notes. What do you think?
That sounds like a great idea.
All right. Folks, we will be right back. This is KF7IJZ with KJ6VU.
This portion of the Photon Podcast is brought to you by Bridgecom Systems and their new 220 handy-talkie, the BCH220. This has been the year of the handy-talkie for Kel, and I'm really enjoying this one as well. Works great on our Bridgecom Club repeater on 220, so make sure you check them out. It's bridgecomsystems.com.
All right, and now we are to what I think is going to be the most fun section of the show, and that's great, Jeremy George. We've covered all of these microcontrollers and embedded systems and raspberries and PICs and all this. But what do I use this stuff for as an amateur? What does this have to do with ham radio?
Great question. I think it really depends on what you are into in ham radio. So learning about microcontrollers and Raspberry Pis and all that just for their own sake is good. But if you have an application where this stuff is useful, then so much the better. So should we start with the microcontroller side or with the embedded Linux side?
I would start with the microcontroller side just because, like I said, I think it's been around longer.
Yeah. And there's so many applications. The way I would look at it is if I want a custom logic function, in the old days, I would have tried to figure out what logic chips I should hook together to give me that function. So if I were going to make a keyer, for instance, I would have to come up with a circuit with 6 or 7 logic chips hooked up to behave like a keyer. Well, today I just use the microcontroller, and I have to figure out how to do that logic in the software. So it depends on the problem you're going to have. So we did a little PIC development board, and we had a lot of people using that to build all kinds of ham radio projects. And they were building excuse me, that was my dog.
That
Here,
wasn't
Bill,
that wasn't
my
stomach.
No, it wasn't dinner. That was the dog. The dog is looking for some food. Of course, that's what the dog sleeps or looks for food. I mean, it's got two modes. It's a binary animal. It's looking for food right now. It's in the one state. So anyway, we had a bunch of people who came up with projects for microcontrollers. A good buddy of mine has this big contest station, and he wanted a smart dummy load. I swear to God, a smart dummy load. And so he built a dummy load, and he put fans on these big resistors and heat sinks, and then he put temperature probes on the fan or on the heat sink to monitor the temperature of the dummy load, which you kind of get the hint that he was running a lot of power. So he wanted this thing to set 3 temperatures, and when it hit the first temperature, it would turn on a fan. When it hit the second temperature, it would turn on the second fan, and when it hit the third temperature, I think it would send off an alarm. So this was a really great, simple application where you're reading a temperature and you're making a decision to flip on a relay that turns on a fan or turns on a big light. Great application. I would never use a Linux board for that. I would only use a microcontroller for that because it's simple enough that you can get away with using a microcontroller.
Well, and you need, I mean, that's something I think kind of left unspoken is the microcontroller running the program is probably a lot more stable than having an operating system where there's 14 million programs running that could possibly go awry and, stop your program from running.
It's totally true. And I definitely feel that way myself. If you're an embedded Linux guy, you're going to say, well, wait a minute. I'm a smart guy. I know how to control the Linux environment. My Linux thing won't be unstable. Look at my router. It runs Linux. It's super stable. What are you talking about?
I have to reboot my router every week, and it runs Linux.
And you don't want to reboot your pacemaker, which is why they don't run pacemakers on embedded Linux. But the other thing that's a big difference between – my dog is just running around going crazy. The big difference between embedded Linux and microcontrollers is also that the – embedded Linux environment is more complicated. You can run multiple tasks. You can have multiple users. You have permissions. You have all kinds of security stuff that you don't have in a microcontroller. So, that's a whole other layer of complexity with Linux. So, other embedded Linux or other microcontroller projects, we built a repeater controller out of microcontrollers. And that's another example where the thing has to be rock solid, super reliable, flip on, start working in an instant, and the thing can't just hang. It's got to always run. It has to be robust. So microcontrollers are the way to go for a project like that. Go ahead.
Oh, go ahead.
No, go ahead.
I was going to say, I when I first got into Arduino, I started doing a lot of research to try to figure out, how can I incorporate this with amateur radio? Actually, probably one of my favorite projects that I have come across that is both surprisingly effective and surprisingly inexpensive is building an antenna analyzer out of an Arduino and a cheap direct digital synthesis waveform generator. We're going to put a link to a couple of these projects in the show notes, but there's a ham K6BEZ and another ham whose name is Jim Harvey, but I couldn't find his call sign, that basically give you the step-by-step instructions to go order an Arduino, go order one of these DDS synthesizer boards off eBay for a couple of bucks, get a couple of analog components and an RF connector, a little bit of soldering, a little bit of copy and pasting code, and bam, you've created an HF-capable antenna analyzer for like $40.
Yeah, it was a matter of fact. K6BEZ is a good friend of mine. That's Barrick Dunn, and he's a member of our club. And when he was working on that project, I gave him our dev board to do the code development on a PIC for the antenna analyzer, and so he wrote the code on that, and then talked to a PC to display the data.
Hi, my name's George, and I will see your Arduino project and raise you with, this guy's a buddy of mine.
So anyway, but it is a great project.
Is Barrick going to be at Baycon?
Oh, Barrick's presenting at Baycon. He's presenting on software-defined radios.
Ooh.
He's doing the intro session.
We might have to have him on the show then to kind of talk about some of these projects. It's just, being a tinkerer with ham radio and this stuff. But okay, so I'm sorry. You shouldn't have let me go. You should have told me about your next project since you're going to trump me like that.
Sorry, I couldn't resist. But by the way, Barrick is he's a professional RF engineer and has been doing that for a very long time. And so one of the points he made about the antenna analyzer is that the $40 to roll your own antenna analyzer was not too far off of the $10,000 professional vector network analyzer that was analyzing the same system. So,
wow.
Of course, it wasn't the same, but it was, for our ham radio purposes, close enough.
It's going to be better than an MFJ 259 Bravo.
Well, it'd be fairly graphical, and what's cool about it is Barrick open sourced everything. So here's the microcontroller code, here's the PC software and Visual Basic. You can take it from there.
Wow. All right. So what else do you got for microcontroller projects using Arduino or PIC?
Oh man, lots of physical monitoring applications. Things like at our repeater sites, we monitor the vital signs like the health of the physical plant infrastructure. So we monitor temperature of the PA, we monitor the battery voltage, we monitor the AC line voltage, we monitor the temperature in the room, we monitor if the cabinet doors are open or not. So any kind of measurement is great for a microcontroller. And then, of course, once you measure it, if it's not in the tolerance, if something's wrong, then you can take some action. So what we do is we monitor all these points in the repeater site, and then we ship that data to a website, and we can monitor the state of the repeater site. And if something goes out of whack, like, for example, a digital watt meter. So you can take a directional coupler. A directional coupler is a little box with two connectors on it, and you run your coax into and out of this thing, and it's going to look at the power going up the coax and the power reflected back from the antenna. It's what's in a watt meter. And a directional coupler gives you a voltage that you can convert into a wattage. And you can have the microcontroller monitor the forward and reflected power, and when the reflected power is high, it can alarm. So in the case of a repeater site, we actually have these things in our feed line going up to the antenna. So if the antenna system fails, then we'll get a text message that says that the power output, the reflected power is high. And that's all being sampled by microcontrollers.
Wow. So do you have those reporting over Ethernet or Wi-Fi to some other system further upstream?
Yeah, in those cases, we have internet access at the repeater site. So what we do is we have a sensor that has two analog to digital converters, one for forward and one for reflected power. The microcontroller constantly reads those voltages, and then it transmits that data over a little wireless data link to a BeagleBone. And the wireless data link are these little XB radios, 2 gigahertz unlicensed data radios, and it just squirts the data to the BeagleBone. The BeagleBone then takes that data and shoves it up to a server, and the server is running on Amazon, on AWS. So we shove it up to the Amazon server, and then we serve off the Amazon web server the state of the sensors. And we have an algorithm that's running on the server so that if the reflected power goes over a certain threshold, like over 3 watts on a 50-watt transmitter, then it sends me a text message.
Wow. Yeah, we probably could do a whole episode on luxury repeater site management.
Yeah.
Because I was going to say, some of the other projects that I have run into before is that a ham K3NG, do you know him?
No, I don't.
Okay. K3NG started a project a while ago. It's been at least a handful of years, 3-4 years, to build the ultimate CW keyer. And what's kind of cool is he's built an Arduino-based keyer that has every function you could ever want, from beaconing to decoding, to interfacing with straight key or bug or paddles, code trainers, all kinds of stuff. And what's cool about it, though, his program is too large to fit in an average Arduino's memory, so you have to go through and customize what features you want. But it's a pretty outstanding project, and there are people out there who actually even sell kits to add the extra hardware needed to interface with a key, or to interface with an audio device, or to interface with a computer. And then finally, this was a project that I played around with a little bit as well when I owned an Alex Loop. You're familiar with the Alex Loop?
Oh, sure.
Yeah, the Alex Loop is this $360 handheld, like 3-foot diameter portable mag loop antenna. That's quite popular with backpackers. But its biggest downfall is that the capacitor that you have to tune the antenna is very fidgety. And you don't really want to be holding this thing necessarily when you're using it. And it's, a lot of work to kind of keep it tuned. So several folks out there have built projects to basically use Bluetooth and an Arduino to be able to remotely tune, and a little motor to be able to remotely tune this thing. KK5JY has a really good write-up on a general purpose remote capacitor tuning system. All of these we'll have links for in the show notes. But honestly, when I was doing research for the show and from our own experience, because if you go back to the D-Star episode, we both talked about running hotspots off of Raspberry Pis. So let's shift to the single board computers.
I think that D-Star hotspot is a fabulous example. There's a case where the original software runs on a conventional computer, and now you have this computer shrunk down so small and running on so little power that it's super portable. And like you said, D-Star hotspot on a Raspberry Pi works beautifully.
And what's kind of cool is that there are at least 3 or 4 different options for this now, because if you're using conventional high-powered radios where you just have a DV, a node adapter that's just the GMSK modem, there are serial boards available that can connect to the Pi over a serial interface. There are even, I think there's one person out there, and I couldn't find this, but I could swear there's somebody who makes a hat that plugs directly into the GPIO pins on a Raspberry Pi to give you that functionality. Now, there is another board out there similar to the DVAP dongle, or the digital voice access point, that has a built-in radio with the modem, or a built-in radio that interfaces with the D-Star network. So we talked heavily about the DVAP, but there's also the DV Mega, which is a card that can either have a 2-meter, a 440, or both 10 milliwatt radio, in addition to the other hardware that plugs right on the Raspberry Pi, that literally you give it power and internet and boom, you're connected to the D-Star network from anywhere in the world.
Yeah, and that's a really nice little package. You hear about those constantly on the network. Lots of guys running those things.
Probably the coolest device in that realm is a USB device called the DV4 Mini, and this is particularly notable because this is the first device that will allow you to interface with D-Star, Digital Mobile Radio, or DMR, and System Fusion, as well as P25, all with one device and one set of software.
Yeah, and some of our club members have bought those things. I'm really curious to see how well it does all that. So if it does all that really well, that's pretty amazing.
Another project kind of related to the peripheral with the Pi is the Raspberry Pi actually makes a fairly good APRS terminal. You can connect it to your standard serial TNCs, through the built-in UART pins. But there is also the folks that make the TNCX make a TNCX for the Pi that actually connects to the GPIO pins. And on the Pi, you have 2 packages of software, at least 2, that you can run to do full desktop mapping, or to act as the controller for a digipeater. You can use these things to iGate to get packets heard into the internet network. But the two softwares are a software called Xastir, Xastir, which is generally available through apt-get installation. It's fully featured, but the thing that stinks is by default it uses very low-quality vector maps. And it will work with OpenStreetMap, but boy, is that a pain. Have you ever tried that?
I have not. No, I haven't.
The other software is a Java-based application that I think is a little bit newer called Yak, yet another APRS client. And I actually heard about this from the Linux and the Hamcheck folks, but it is also a fully featured lightweight APRS client that very easily interfaces with the OpenStreetMaps to pull down OpenStreetMap tiles for both online and offline modes. Again, links to all this in the show notes. One other D-Star usage we didn't talk about is there are folks out there that actually build lightweight, low-power portable computers to be able to run software in the field with them. So for the emergency responders that use DRATs that we talked about in the D-Star show, there are instructions out there on how to get DRATs to run on your Raspberry Pi with your little lightweight portable computer plugged into a D-Star radio. And similarly, there are folks who will use Raspberry Pis in the field to run FLDigi to be able to run their favorite digital modes from a lightweight, low-power computer that goes into the field.
I've got a couple other projects here along those lines, too. We do Field Day every year, and for Field Day, about 2 years ago, we decided to move from laptops to tablets for logging. And so Nick N3WG, who's also in our club, wrote Hamlog. And Hamlog is real popular for using for portable operating on Android and iPhones and such. So I asked him if he would enhance Hamlog to have a field day mode, which he did, and it works great. And then we figured, well, we need a server because every station is going to log, and you want it to all go to a central server. So he took a BeagleBone Black, and we plugged it into a Wi-Fi access point, and he wrote a little software on the Black, and it pulls all the clients, whether they're Androids or iPhones or whatever, grabs that data and has a centralized server running on the BeagleBone. And so we have a little plastic like ammo can that's got a BeagleBone and a Wi-Fi AP and a big battery, and that's our server for login.
That is that is really cool.
Yeah.
I was going to say, is the software available?
He never turned it into a product, but we run it. We've run it for the last 3 years, so it definitely exists. I may have the only copy in the world, but maybe if you twist his arm, he might let a copy loose. What's very cool about it is on your phone there's a button that says email log, and you hit the button, you type in an email address, and it sends the entire log from the Beagle server to whoever you email it to, and that's how you then upload it for your contest.
Nice. We talked about repeater controllers, and actually one of the core pieces of software for using the Raspberry Pi as a hotspot is a piece of software by Jonathan Naylor called the PC Repeater Controller, which allows you to actually run conventional repeater controllers by interfacing the Pi with the Velamin serial control board, or you can use it to run a D-Star hotspot. I also became aware of a new project called the Open Repeater Controller Project. Also have links for those.
No, hang on. You can't get off the repeater controller thing without me putting in a plug.
You're right. I apologize.
So a shameless plug. So I would, when you run a repeater, if you're running it in a location where it cannot fail, it cannot get stuck on or anything, I'm not so sure I would use a embedded Linux platform for that. Remember Jeremy's comment about having to reboot his router? So our repeater controller philosophy is the core functionality, the things that control the transmitters, has to run on the microcontrollers because we wrote every line of code, we know exactly what it does, and it's very robust. Having said that, there's a lot of functionality that you can add when you couple those microcontrollers to a BeagleBone or to a Raspberry Pi. So in our repeater controller, we've added a host adapter board, so you can plug a a Linux board right into the rack along with the rest of the repeater control logic. What that gives you is all this Linux programmability, but it doesn't get in the way of the real-time kind of mission-critical task that the repeater controller has to perform. So that's how we kind of get both sides of it, our cake and eating it too. And this sort of brings up a big philosophical point, which is it's not always either or. It could be and. So it could be that your big fancy project could be most well suited by a combination of an embedded Linux board as the communications and user interface stuff, and one or more microcontrollers as the real-time, high-speed kind of physical interface.
And I don't think you mentioned who we is.
Oh, so we is Sierra Radio Systems. So Sierra Radio Systems is a little company that I started with another fella, John, KJ6K, and he and I developed a family of repeater control systems. We started building them for our big link network, which is called the Cactus Intertie. And we've had a lot of groups who've bought them over the years to build their linked repeater networks.
Very good. Otherwise, that would have been a pretty terrible, shameless plug.
Yeah, exactly. So I'm sure there'll be a link in the notes on that as well.
Yes.
But here's while we're at that, let me just add one more thought. So, why would you put an embedded Linux board into a repeater controller if the core is already done? And the answer is there are some things that are better done on Linux. So we wanted to add a voice capability to the repeater controller. And the way it was done in the past is you'd have a voice synthesis chip, which are largely not made anymore. How do you solve that?
Time is 14:22.
Yes.
On frequency Thursdays at 7 p.m.
Exactly. So for when we went to implement voice, what we did was we took we made a host adapter board that plugs into the rack, into our card cage, and we made one for a Raspberry Pi and we made one for a BeagleBone, and we created a voice library. So we've got 1,000 words and phrases that are in MP3 file format, and they sit on the Beagle's SD card, and we wrote a Python program that lets you interface it to the repeater controller. So, for example, the embedded Linux has the cron scheduling utility built into Linux that lets you say, on every alternate Thursday at 2 p.m., do this. So if you want to have, let's say, that program message like net tonight at 8 o'clock, the cron task in Linux fires off whenever you want the announcement to go out. It keys up the repeater system, and then it plays whatever MP3 or WAV file you want. So rather than it being this kind of staccato, synthesized, crappy voice, it could be anybody who's recorded a WAV file or an MP3 file, and it plays that message. So it's super easy to change the messages. You can rotate the messages, and it's all written in Python. And you can also cobble together your own messages if you want. So adding voice, doing voice in Linux is way, way easier than doing it in a microcontroller. Doing a scheduler like the cron scheduler in Linux is way easier on Linux than writing a sophisticated scheduler routine in a microcontroller. So there are definitely times when the combination is really much more powerful.
Well, and there are a ton of other projects out there, and without deep diving in a couple of other on the Raspberry Pi side, if you are interested in tracking airline traffic over the air using one of the new RTL SDR dongles and a Raspberry Pi, there is software for ADS-B tracking out there that's free. There are also several Pi SDR projects to actually use the Pi to give you a Spectrum and waterfall display using an RTL SDR dongle. We also have, I actually came across a really cool one where somebody was actually using some Pi output pins as an FM transmitter. There's other projects for the Arduino. I can't believe I didn't mention this, and there's just not enough time to dig into it. But people sticking Arduinos with little micro-powered, flea-powered FM, 2-meter radios, and doing APRS for high-altitude balloon tracking or model rocketry tracking. Mm-hmm. So along that line, there was a project on Kickstarter this year called the Ham Shield, which gives you a VHF UHF transceiver that plugs right into the standard Arduino Uno pin output. I mean, there's just so much out there. And again, we put together some really good links for all of this. I think that kind of covers it. I think there's only one other thing to do, but is there anything else you want to add in closing on the topic?
Yeah, I guess just two thoughts. One is, turns out this month's Make magazine has an excellent overview of a lot of these boards that are out there. So if you get Make magazine for February and March, volume 49, the cover says "Super Cheap Computers: Your Guide to 40 Boards," and this little pull-out guide lists a big table of all of these boards: the Raspberry Pi, the BeagleBone, the Arduino, a bunch of new stuff like the Chip, which is a $9 board like the Raspberry Pi. There's a bunch of other ones. So I'd get that copy of Make. That's a great resource. The second thing I would suggest is maybe in a future episode, maybe you and I should each pick a project, maybe a Linux project and a microcontroller project, and rather than talk about all of this stuff in a big way, just talk about that one particular project and how you built it.
I like that. Okay. I think the thing I would leave people with is that don't be scared of the sheer amount of material we just dumped at you. Google is your friend. Either one of these platforms is very easy and very approachable due to its expense, due to the amount of community support there are out there for these products. And it's something that, they unlock a ridiculous amount of creativity. And one of the things that I think you and I take for granted, George, is that we have more available to us to rapidly put solutions together like this than anybody in history. It is such an exciting time to be alive at the explosion of all these small little boards that do really cool stuff.
And this was stuff that you would have to be a professional developer 20 years ago to really do yourself. So you're totally right on, Jeremy.
Maybe 10 years ago. So speaking of that, it's time to figure out how to get some of this stuff in the hands of our listeners.
Ooh, that would be exciting.
Yes. So here's what we're going to do. In the past, we've asked you to send emails, and we're going to ask you to send emails again. But this one is a little bit more work is involved. We have to give away one Raspberry Pi 2 as kind of our grand prize, and then 2 Arduino Uno compatible boards that will be courtesy of me, Cale, and George. And what we're going to ask is we want you to send an email to Cale, C-A-L-E, at amateurradio15.com. That's all one word. Include your call sign and give us a little bit of a write-up what you would do with an Arduino or a Raspberry Pi. It can be short. It could be one sentence. It could be, I just want to play with it.
Hey, let's throw another thing on the pile.
Okay.
I've got PIC development boards that you put together yourself, and the compilers are free, and there's a whole tutorial on how to do it. So why don't we throw a couple of PIC development kits in there too?
Okay, so you heard that. That's a grand prize of a Raspberry Pi 2, 2 Arduino Uno compatible boards, and a couple of PIC development kits. So again, send an email. I forgot to tell them, what should we make the subject line be? How about faux make?
You better spell that.
Yep. So it's not fomaki, some great Japanese dish. So in a subject line, to be very clear, put the word faux, F-O, space make, M-A-K-E, include your call sign, and give us a line or two about what you would make if you were to win one of these boards. When Cale gets back from his wilderness survival training in the Great Smoky Mountains, we will have him pull these together. And again, that email address is Kale Charlie Alpha Lima Echo at amateurradio15, all one word, and 15 is the number, amateurradio15.com. I think that's it.
I would suggest one last thing.
Please.
We need a Jeremy shopping list. So if someone leaves this podcast right now and runs out to their closest web browser and orders a thing, what would you have them buy?
Oh, wow. Truthfully, I'm going to have them buy a Raspberry Pi because I think they could get up and running with a Raspberry Pi, probably with things they already have in their house, and could start playing with the Linux and software portion of it today.
I think that would be good advice. I'll give you my version.
Please.
I would, in spite of being a kind of a pick guy, I would say go out and buy an Arduino Uno board. And the reason I suggest that, besides everything we've already said, is that the programming complexity is really simple on the Arduino. You don't have to deal with the operating system. So I think, if you're kind of a Linux savvy guy, you'll love the Pi. You'll be right at home. If the computer programming sort of environment freaks you out, start with the Arduino.
We have some friends who would tell us to get both, and I say, go out and get a Raspberry Pi, connect it to an Arduino, have it the Pi get on the internet and get the time, and have it blink the LED on the Arduino
in CW
in CW for prime numbered seconds.
Exactly. That's the project.
You could do that.
You could. That's awesome.
All right. I think that's it. George, thank you so much as always. It was great spending some time here with you.
My pleasure, Jeremy. Thanks, and Happy New Year.
Happy New Year to you as well. I look forward to our next episode. Kale, the good news is we didn't burn the place down, but we drank all your beer.
But there's a few more miles on the Porsche, man. Sorry about that.
All right. 73, folks.
Bye-bye.
Okay, that's going to wrap number 43. George, Jeremy, thank you so much. You always do a phenomenal job, and we appreciate you giving us your time. Folks, we appreciate you listening, and don't forget the giveaways. It's there. You just have to do what they ask you to do. Send the emails in, and the randomizer will pick some random winners. Hey, don't forget, Winter Field Day is coming up January 30th and 31st, 2016, and we have a lot in store for you over the course of this coming year, 2016. It's not coming anymore. We're in it, so we appreciate you being here. We always thank you for hanging out with us. Again, George and Jeremy, we really, really sincerely appreciate you taking the reins on this microcontroller show. I'm sure there's more to talk about we'll get to as time progresses here on the program. But until then, we'll catch up with you next time, guys. Thank you so much. 73, y'all.
Thanks for listening, downloading, and subscribing to Photime, the other ham radio podcast, presented by mtcradio.com. To subscribe, comment, share, or review, visit our show site at photimepodcast.com. Till next time, 73, y'all.